Hello guys, welcome back to chapter 1 of mechanics course revision questions. I will continue solving from section 1.7. So section 1.7 is only one question, which is 10 grid. When a car moves from an asphalt road into a rough dirt patch, its speed decreases, pay attention, from 20 meters per second to 12 meters per second in 2 seconds. What is the average acceleration of the car? Very simply, you're gonna take velocity final, okay? You're gonna subtract it from velocity initial and divide it from the time. So 12 minus 20 divided by 2, that's gonna be minus 4 meter per second squared. So that's it for section 1.7. We will move on to section 1.8. What does it say in section 1.8? The diagram below shows the variation of a subway's train velocity with time. What is the acceleration of the train at time 30 seconds? So at time 30 seconds, we will need to find the acceleration of the train. As you can notice, it is what? It is a straight line, okay? Because it's a straight line, that means what? That means the acceleration is what is constant. Because the acceleration is constant, that means we can find the slope of the line, okay? And when we find the slope of the line, that means it is equal to what? It's equal to the acceleration at all points until where? Until here, okay? So from 0 until 60, it's a straight line. That means the acceleration is constant. So it's a slope, straight slope. So let us find the slope of this line. It's gonna be what? It's gonna be, just to choose, for example, 60, 21, and 0, 0. If you chose this, you will do y minus y over x minus x. So 21 minus 0 over 60 minus 0. Put it on the calculator. You're supposed to get 0.35 meters per second squared. So at 30 seconds, the acceleration is supposed to be what? It's supposed to be 0.35 meters per second squared. In what time interval is the magnitude of acceleration of the train the greatest? So visually, it's kind of easy to see. Okay, they want the magnitude of acceleration of the train that is the greatest. So when it is the greatest, it's usually when the slope is steeper. So I cannot talk, my bad. So when the slope is steeper, the steeper the slope, okay, the greater the acceleration. The steeper the slope, the greater the acceleration. As you can see here, this is like pretty average, okay? This is flat. So the slope is equal to 0. If the slope is equal to 0, it's not gonna be. But this one, as you can see, it is steeper, okay? So if you calculated the slope of this one, it would be a greater value than the slope of this one. So definitely this one has what? A greater magnitude of acceleration because it has a steeper slope. So part B, the time interval they need, so it's from 90 seconds all the way until 120 seconds, okay? Now we will move on to question number 12 grid. What does it say? It says, the diagram below shows the variation of a cyclist's velocity with time. They said, explain how to calculate the instantaneous acceleration of the cyclist at time 10 seconds. Now pay attention, they want the instantaneous acceleration and not the average acceleration. So very simply, the first thing we're gonna do is we're gonna draw a tangent. So draw tangent, okay, to the velocity time curve, to VT curve, at 10 seconds. So at 10 seconds, okay, so you will draw the tangent to the velocity time curve. My bad, I don't know what's happening to me. draw the tangent to the velocity time curve at 10 seconds, okay? Now, the next step you're gonna do is you're gonna draw a right triangle for which the tangent line is the hypotenuse. So draw, this means a right triangle where tangent is hypotenuse, okay? And then the third and final step is to what? Is to find the slope of the tangent line. So slope of tangent line, this is equal line. This is equal to what? This is equal to the acceleration. So again, first thing you need to do is you need to draw a tangent to the velocity time curve at 10 seconds. After this, you will need to draw a right triangle where the tangent is the hypotenuse, and you will need to find the slope of the tangent. How do you find it? You can do what you can do, the rise over the run. So what is the rise? The rise is going to be the y-axis and the run is going to be the x-axis. Very simply, this is how you calculate the instantaneous acceleration of the cyclist at a specific time given a curved graph. Now, so question number 13, the velocity time graph of a particle is shown below. Calculate the average acceleration, the average acceleration of the particle between time 2 seconds and time 5 seconds. So what you're going to do, because we're looking for the average acceleration, you will take the 2 points, 2 and 5. You will draw a secant in between them. Let me draw a proper secant like this. You will find the slope of secant. The slope of the secant is equal to what? It is equal to the average acceleration. Forgive me, I don't know what I touched. Can just leave it like this. So now you just need to find the point. So this point is approximately 2,4. And this point is approximately 525. Now that you have the 2 points, you will find the slope. So y minus y over x minus x. So 25 minus 4 over 5 minus 2. This will give us what? This will give us 21 over 3, which is what? Which is 7 meter per second squared. So the acceleration is 7 meter per second squared. We move on to question number 14. It said, why is the velocity time graph of a body moving in UARM linear? Very simply. UARM means what? Uniform or constant acceleration. And velocity time graph, the slope is equal to what? Is equal to the acceleration. So if the acceleration is constant and the slope is equal to the acceleration, then for sure it's going to be what? It's going to be linear. It's going to be a straight line, basically. Does a positive acceleration always mean a body is accelerating? This is a very good question. A positive acceleration means that the body is accelerating. So positive acceleration. Okay, let me just write it. A positive acceleration only means a body is accelerating if it is moving in the positive sense. So if it's moving in the negative sense, it's not accelerating, it is decelerating. However, if it's moving in the positive sense with a positive acceleration, then it is what? It is accelerating. So remember this one question in the quiz, it was a positive acceleration in the positive sense. It's going to give us what? Positive times positive. It's going to give us a positive acceleration. However, if it's moving in the negative sense, but it has a positive acceleration, it's going to give us what? It's going to give us negative. So it's not accelerating, it's decelerating. Okay? Or for example, if it's negative, if it's moving in the negative sense and it's a negative acceleration, then it's what? It's accelerating. But if it's moving in the positive sense and it has a negative acceleration, then it is what? It is decelerating. Very simply. Question number 16. Consider the velocity time graph of a particle. The instantaneous acceleration of the particle at time t is 5 seconds and its acceleration at time 7 is this. Okay, what did I say? The instantaneous acceleration of the particle at time 5 seconds is a5 and its acceleration at time 7 is a7. Compare the magnitudes of these accelerations. So look at a5, as you can see what? As you can see, the slope is less steep than what? Than at a7. So here slope is more steep. So remember, the steeper the slope, the greater the acceleration. That means for sure a7, for sure that means a7 is what? It is greater than a5. Very simply. We'll move on to section 1.9, motion with a constant velocity. At 1 p.m., this is the time, okay? A car is spotted traveling at a constant velocity of 25 meters per second towards a street sign. 2,000 meters away, determine the equation of motion of the car. Okay, so very, very important. The first step we will need to do is choose what? A frame of motion. Let's say we chose the street sign as the frame of motion. What does it mean, frame of motion? That means the street sign is the origin, where the position is equal to 0. It's traveling with a constant velocity of 25 meters per second towards a street sign, 2,000 meters away. So the street sign is what? 2,000 meters away, okay? So they want the equation of the motion of the car. Whenever they say equation of motion of the car, that means they want to find what? They want to find x final. Very simply, we know x final is equal to what? It's equal to x initial plus velocity times time. Right? So x final is equal to x initial, which is 2,000 meters away. If the street sign is 0 and this is 2,000 meters away, okay? And we are accelerating at a constant velocity, that means, sorry, not accelerating, we're speeding at a constant velocity, and our velocity is what? It is positive, that means it's going towards the street sign, then that means for sure that this is gonna be negative. So x initial is minus 2,000. Why? Because we have a street sign, right? Its initial position is 0. Then this is 2,000 meters away from the initial position, so minus 2,000. Okay, in addition to what? To the velocity, which is 25 times the time. So the final equation is x final is equal to 25t minus 2,000. Very simply. We'll move on to section 1.10. What does it say in section 1.10? It says, the diagram below shows the variation a cyclist's velocity with time. What is the total displacement of the cyclist in 20 seconds? So look, they gave us what? They gave us a velocity time graph. They want us to find the displacement. Remember, velocity times time is equal to the displacement. So to find the area of the graph, you would have found what? You would have found the displacement. But remember, displacement, we don't denote it with d, we denote it with delta x. So we would have found the displacement. So let us find the area of this graph. Very simply, to find the area of this graph, you need to find the area of a trapezium, because this is a trapezium. So let's find the area of the trapezium together. It's base 1 plus base 2 times the height over 2. So let's bring it here. Base 1 is from 0 to 20, so 20. Plus base 2, which is from 5 to 15. What's the difference? 15 minus 5, 10. So 20 plus 10 times the height, which is 6 divided by 2. Put it on the calculator and you will get an answer of 90 meters. So the displacement of the cyclist in 20 seconds was what? Was 90 meters. Whew, this is a big question, big section. It's 1.11, motion with a constant acceleration. Okay, let us do 19 grid. A toy car is initially moving in the positive direction at 0.5 meter per second. So this is V initial. At time 0 second, this is time 0, the car accelerates at 0.20 meters per second. This is the acceleration for 6 seconds. This is the time. What is the displacement of the car? So here, look what we're gonna do. We're gonna apply the equation that the displacement, okay, delta x, is equal to what? To velocity initial times the time, plus 1 over 2, okay, times acceleration times the time squared. So delta x is equal to velocity initial, which is 0.5, times the time, which is what? What's the total time taken? It's 6 seconds. Plus 1 over 2 times the acceleration, which is 0.2 times 6 squared. Put it on your calculator. Times 0.2 times 6 squared plus 6 times 0.5. It is supposed to give you an answer of what? Of 6.6 meters. So the displacement is what? 6.6 meters. Now, we move on to this question over here. Question... Go, I don't want you. Ignore this, okay? So question number 20. The position of a particle moving along the x-axis is given by this equation. They said, determine the characteristics of motion of the particle. So very simply, what I'm gonna do, first of all, is we have what? We have the distance. So let us take the derivative. So let's find the derivative, dy over dx, to find the velocity. If you do dy over dx, you're gonna get what you're gonna get? 3 minus 4t. This is now the velocity. Velocity is equal to 3 minus 4t. طيب, let's do the discriminant the derivative one more time to find the acceleration. So acceleration is equal to what? It's equal to minus 4 meters per second squared. So as you can see, because it's one value, there's no t, there's no variables, it's just a constant value. That means that the motion is what? It is UARM, because the acceleration is constant. So it's UARN, uniform accelerated rectilinear motion. Part B, describe the velocity of the particle at time 3 seconds. Remember, to find the velocity, you need to take the the derivative, not the discriminant. So the discriminant in this case is gonna be, I keep on saying discriminant, guys. Sorry, my head is stuck in math. The derivative, okay? So take the derivative of this to find the velocity. Velocity is equal to what? To 3 minus 4t. Now they want it at time 3 seconds. So you will substitute the t by 3 seconds. So it's gonna be 3 minus 4 times 3. So 3 minus 12. That's gonna be what? It's gonna be minus 9 meters per second. Okay, so that is it for part B. Now we move on to part T. They say what? The average velocity of the particle between time 2 seconds and time 6 seconds. So how do we find the average velocity? First of all, we need to find the total time. What's the total time between 2 seconds and 6 seconds? That's 4 seconds. Then we find the total distance. How to find the total distance? First, you're gonna, not the total distance, sorry, the displacement. So you know that average velocity is equal to what? To displacement delta x over time. So the time we found it to be what? To be 4 seconds. Whereas the delta x displacement is gonna be what? It's gonna be the position at time 6 seconds. So it's gonna be 3 times 6 minus 2 times 6 squared, okay? So put that on the calculator, 3 times 6 minus 2 times 6 squared, that's gonna give us what? Minus 54. So this is what? This is velocity final. So minus 54. And we're gonna subtract it from what? We're gonna subtract it from velocity initial. How do you find velocity initial? You will substitute 2 over here. So velocity initial is equal to what? It's equal to 3 times 2 minus 2 times 2 squared. So 3 times 2 minus 2 times 2 squared. This will give us an answer of what? Of minus 2. So minus 54 minus minus 2, that's going to give us an answer of minus 52 over 4, which is then what? Which is minus 13 meters per second. So the average velocity, we found the displacement, we put it over the time, and we got what? Minus 13 meters per second. So question number 21. A car is moving at a speed of 30 meters per second. This is the speed of the car along a road where the speed limit is 80 kilometers per hour. Here you have to divide by 3.6 in order to get it in meters per second. So it's it's 22.222, etc., right? A police officer on his motorcycle spots the speedy car and starts chasing it 2 seconds after the car passed him. So 2 seconds after the car passed him, the officer noticed what? The officer noticed that the car was speeding. If the car and the motorcycle are moving along a straight path, okay, find the distance covered by the car before it is caught by the police officer. Given that the motorcycle accelerated from rest at 6 meters per second squared, take the origin of time and frame of reference as the point at which the speeding car passes the police officer. Okay, so they want to find what? The distance covered by the car. So first of all, we need to know by taking what? By taking the point at which the speeding car passes the police officer as a reference, we need to know how much did he travel before the police officer started speeding, or like started moving. So, started chasing it, sorry. So for 2 seconds, the police car was, the police officer was on his motorcycle stable, and then after 2 seconds, he started chasing it. So he's moving 30 meters per second, and in 2 seconds, he would have moved how many meters? He would have moved 60 meters, because 30 times 20, 60 meters. Plus, because there's still, after the car passed him, there's still the time that he traveled. So 30 times what? Times the time. You can apply this as what? You can apply this as x final is equal to x initial plus what? The velocity times the time. So this is the velocity, this is the time, this is what? This is x initial. Then they said what? He accelerated from rest at 6 meters per second. Okay, so we can say that he accelerated uniformly. So the equation we will use in this scenario is this equation, 1 over 2 times acceleration times time squared plus velocity initial times time plus what? X initial. So look, whenever you see URM, you should know that the equation you are going to use is what? URM, the equation you're going to use is x final is equal to x initial plus velocity times time. Whenever you see UARM, you will know that the equation you will use is 1 over 2 times acceleration times time squared plus velocity times time plus x initial. So in this case, let us find the time. Okay, so we have the acceleration, it is 6, so 1 over 2 times 6 times t squared plus velocity initial. So it accelerated from rest. Pay attention, it accelerated from rest. From rest meaning that velocity initial is equal to 0. So plus 0 times the time plus x initial. X initial is the police officer, so it's 0. So this will leave us with what? It will leave us with 3t squared. So if you solve this, you will get rid of this and you will be left with 1 over 2 times 6 times t squared, which is 3t squared. 3t squared is equal to what? So let me clear this up again. Remember that the equation for the car was 60 plus 30 times time. This is what? It's equal to x final. And for the motorcycle, it was what? 3t squared. So very simply, you can substitute this in this. So 3t squared is equal to 30t plus 60. Move these to the other side. 3t squared minus 30t minus 60 is equal to 0. So you will put it on your calculator mode 5-3, or you can solve it by using the discriminant method. So you will do b squared minus 4ac, and then the roots is equal to minus b plus minus radical discriminant over 2a, okay? Or you could put it on the calculator. So 3 minus 30 minus 60. So a is 3, b is minus 30, c is minus 60. You will put it and you will get two answers. One answer, so t1 is equal to 11.7, and t2 is equal to what? It is equal to minus 1.7. So which one will we take? First of all, can time be negative? No. So you'll get rid of this and you will take this. Now they want what? They want the distance covered by the car. So you'll go back to the distance covered by the car, which is 60 plus 30 times the time. We have the time, which is 11.7. Just substitute it. So it's going to be what? It's going to be 60 plus 30 times 11.7. And you will get what? The total distance covered, which was 411 meters. Very simply. Okay, that was a good hard question. We move on to question number 22. A particle initially moving at 10 meters per second, this is v initial, is decelerating at a constant rate of 25 meters per second squared. This is the acceleration. What is the displacement of the particle over a course of 6 seconds? So, we need to apply the equation of the UARM. Why? Because it's a constant acceleration. So you'll apply the equation 1 over 2 times acceleration times time squared plus velocity initial times time plus x initial is equal to x final. So in this case, x final is equal to what? Is equal to 1 over 2 times. Pay attention, since it's decelerating, that means it's going to be minus 2.5 meters per second squared, okay? Times the time, which is 6 squared. This is minus 2.5, don't forget that. Okay, plus velocity initial, which is 10 times the time, which is 6, plus x initial, which we're going to say 0. Put it all on your calculator, so it's supposed to be 1 over 2 times minus 2.5 times 6 squared plus 10 times 6. It's supposed to give you an answer of what? It's supposed to give you an answer of 15. So very simply, the displacement is 15 meters. Question number 23. A motorcycle accelerates from rest to 30 meters per second at a rate of 50 meters per second squared in t seconds. Calculate the distance covered by the motorcycle. So we have what? We have rest, which is v initial, 30 meters per second v final, at a rate of 5 meters per second squared. This is the acceleration. In t seconds, the time. We don't know what's the time. They want us to calculate the distance covered by the motorcycle before it reaches the final speed. So, very simply, we will need to use another equation because we don't have the time, okay? We need to use another equation that does not consist of the time. Very simply, the other equation is what? V final squared minus V initial squared is equal to 2 times the acceleration times the distance. So, 30 squared minus 0 squared is equal to 2 times 5 times x, distance displacement. So, we will get what? We will get 900 is equal to 10 times x. So divide both sides by 10. So you will get x is equal to 90 meters. So very simply, we found what? We found the distance covered by the motorcycle before it reaches the final speed. Now calculate what? The value of t. We need to find the value of t. So very simply, what we can do is we can use the distance, okay? But in this equation, x final is equal to 1 over 2 times the acceleration, okay? Times the time squared plus velocity initial times time plus x initial. Now let's substitute. So x final is 90 is equal to 1 over 2 times the acceleration, which is what? Which is 5 meters per second times the time squared, which we need to find, plus velocity initial, which is 0, times the time, which is, we also need to find it, plus x initial, which is also 0. So this and this will go away because it's 0 plus 0, which is 0. And we'll be left with 90 is equal to what? Is equal to 2.5 t squared. So divide both sides by 2.5. 90 divided by 2.5 will give us an answer of 36. So t squared is equal to 36. Do radical both sides. T is equal to 6 plus or minus 6. But remember, you cannot have a negative number as the time. So you cannot have minus 6 seconds. Like, that doesn't make sense. So it's going to be plus 6 seconds, very simply. That is it for question number 23. Now, finally, the last and final question. A train moving along a straight track accelerates from rest. So for rest, that's velocity initial is equal to 0. Velocity final is 2 meters per second for 20 seconds time. And then moves at a constant speed for 120 seconds. This is the time as well. Finally, the train decelerates uniformly to a stop in 40 seconds. This is the time. Now, they said write the equation of motion of the train in each phase. Very simply. Oh, this is a big question. So phase 1, let us do phase by phase. Phase 1, it accelerates from rest at 2 meters per second for 20 seconds. I think this is supposed to be 2 meters per second squared. So don't pay attention. This is wrong, by the way. They're not supposed to put it here. They're supposed to be here. So it's 2 meters per second squared. This is not velocity final. This is the acceleration. Okay? So they want to find what? They want to find the equation of motion. So they want to find the displacement at the first phase. So first phase, or x1, it's equal to 1 over 2 times the acceleration times time squared plus velocity initial times time plus x initial. So x initial is 0. Velocity initial is 0 times the time, which is 20. Plus 1 over 2 times the acceleration, which is 2, times what? Times the time, which is 20 squared. So x initial is equal to what? It is equal to 1 over 2, okay, times 2 times 20 squared. So it's going to be what? It's going to be 400 meters. So for the first phase, it is 400 meters. For the second phase, what did they say? They said it then moves at a constant speed for 120 seconds. So, x2, in the second phase, it moves at a constant speed for 120 seconds. If it's moving at a constant speed for 120 seconds, then to find the displacement, it's very simply going to be velocity initial plus velocity times, x initial, my bad, x initial plus velocity times time. Right, so how do we calculate the final velocity? Well, very simply, to calculate the final velocity, you already have what? You have the acceleration and you have the time. So you will find the final velocity by doing acceleration times time. Okay, so it's gonna be 2 times 20, which is what? Which is 40 meters per second. So now that we have the velocity, okay, we can use it to find the distance. So x2 is equal to x initial, which we found from before, which is 400, plus the velocity, which is 40 times the time, which is what? 120. So it's supposed to be 400 plus 40 times 120. And you will get an answer of what? Of 5,200. Now finally, x3, which is the last phase, then it decelerates uniformly to a stop in 40 seconds. So we have what here? We have decelerates uniformly. The velocity that was originally, velocity initial was 40 meters per second. But velocity final was 0. Why? Because it comes to a stop. So velocity final is this. We have the time over here, okay? And we will need to find what? We'll need to find x3. Very simply, x3 is going to be what? It's going to be x initial plus velocity times time. Or actually, let us do it in a better way, because there is an acceleration here, okay? It's not a constant. So we will need to use the acceleration, okay? Because it's decelerating, there is an acceleration, we will need to use UARM. What is the equation for UARM? It is 1 over 2 times acceleration times time squared plus velocity initial times time plus x initial. So x initial, we found it from before, it's 5,200, okay? Plus velocity initial, which is what? Which is 40 times the time, which is also 40. Plus what? Plus 1 over 2 times the acceleration times the time, which is what? 40 squared. How do we find the acceleration? Very simply, you should know that there is an equation for the acceleration. It is what? It is v final minus v initial over the time, okay? So acceleration is equal to v final, which is 0, minus v initial, which is 40 over the time, which is 40. So you will get what? Minus 1 meter per second squared as the acceleration. So instead of a, you can put minus 1. Now put it on the calculator. 1 over 2 times minus 1 times 40 squared plus 40 times 40 plus 5,200. You're supposed to get an answer of what? You're supposed to get 6,000. So I got 6,000. Okay, so that is it for part A. We'll move on to part B, which is the last part. Find the position of the train at time 5 seconds, 60 seconds, and 160 seconds. Okay, so this is actually a very, very, very important question. So we have to see at which phase is it. Is it in phase 1, phase 2, or phase 3? And based on that, we will see which equation are we gonna use. So at 5 seconds, this is in which phase? It is in phase 1, because phase 1 is for 20 seconds. So we will use the equation that we used in phase 1. We know that in phase 1, it is UARM because it's accelerating. Okay, so we'll do 1 over 2 times acceleration times time squared plus velocity initial times time plus what? Plus x initial. So this is 0 plus 0 times the time, which is 20, plus 1 over 2 times 20 squared. So here we're gonna just erase these, but here's the trick. Instead of 20 seconds, we will put what? We will put 5 seconds, because it's no longer at 20 seconds. It is, however, at what? It is at 5 seconds. So very simply, you can put 1 over 2 times 2 times 5 squared. So it's gonna be what? It's gonna be 25 meters. Now, 60 seconds. In which phase is it? It is definitely not in the 20 seconds phase, but however, it is in the 120 second phase. So in the 120 second phase, which equation did we use? We used the velocity, we used x final. Oops, what happened? We used x final is equal to x initial plus velocity times time. So x initial was 400 from the first phase plus the velocity. So it's moving at a constant speed. What is the constant speed? The constant speed is 20 times 2 meter per second squared, which is what? Which is 40 meters per second. This is the constant speed. So plus 40 times the time. What is it? Is what? 60 minus 20. So 60 seconds minus this time. So it's gonna be x initial 400 plus velocity 40 times the time. The time is gonna be time final, which is 60, minus time initial, which is 20. So 60 minus 20. So it's gonna be 400 plus 40 times 40, which is what? Which is 2,000 meters. Okay, so that is 60 seconds done. Now 160 seconds. For sure, 160 seconds is greater than this time period. Now pay attention, you need to add. This is 20 seconds. It then moves for 120 seconds. So now the total time is what? 20 plus 120, which is 140. So still 160 is greater than that. That means it is where it is in the third phase of time. So again, this is UARM. UARM is what? 1 over 2 times acceleration times time squared plus velocity initial times time plus x initial, right? So the acceleration, we found it previously. If you remember, what was the acceleration? The acceleration was minus 1. Don't forget it, okay? How did we find it? We did v final minus v initial over 2. V final is 0. How do we know? Oh, by the way, not over 2, over the time. My bad. So because it stopped, that means it's 0. And then v initial was here, which was 40 meters per second. And then the time is 40 seconds. So 0 minus 40 over 40 will give us minus 1. Plus velocity initial, which was 40. So let's just fill in the blanks. X initial was what? X initial was 2,000. Was it 2,000? No, sorry. X initial, if you remember, we found it to be 5,200, right? 5,200 plus velocity initial. By the way, how did we get 5,200? It's by doing the total distance here, which was 400, in addition to the total distance here, which was what? Which was 40 meters per second times 120, which is 4,800. So we added 4,800 and 400, and we got what? We got the answer to be 5,200. And so the velocity initial is 40 times the time, which is what? 160 minus 140, because remember the total time is 140. So 160 minus 140, which is 20. So 40 times 20 plus what? 1 over 2 times minus 1 times 20 squared. So let's put it on the calculator. 1 over 2 times minus 1 times 20 squared plus 40 times 20 plus 5,200. You're supposed to get an answer of what? Of 5,800 meters. That's it for this video. Thank you guys for watching. I hope you enjoyed and have a wonderful day.